sound now?
Let me try. Yeah, now I can.
Thanks.
Yeah, thank you everyone, and thank you, Peter Brown, for the introduction. I move this one. So yeah, today I was asked to give a presentation about a prototype that we did for other project, like VW data project. So in that project, like what we tried to show was like how to access like a sensitive rare disease data by applying like appropriate like access restrictions applied on those data sets, and these data sets are like distributed in manner. So before I get into the prototype, I would like to clarify a few thoughts about this particular component that we used in this prototype. It's called federated point. You might have heard about it. So I like to clarify the context that we used this component in this prototype. So when I say federated point, like it's a component that we use it as a metadata provider. Meaning like it acts as a description provider of your resources, like the general description of your resource. And if you're talking about data set is usually like distributed in different formats, right? Like those description of your different distributions. And if you have like any use conditions and access rights, those descriptions. So basically like it's just metadata provider. It does only that. So what we did in VW data prototype is like we tried to solve like a data finding use case with as much automation as possible. And the biggest assumption that we made in this prototype is like the resource data set that we are accessing or like fair at the source. Meaning like these data sets are like RDF and they are like deposited in a triplestore at the source. And for implementing this prototype, we reuse like as much existing component as possible. We didn't like implement like anything new. Like we had like one Glue API. Other than that, like we didn't like implement anything really new for this prototype. So let's start with like describing the use case that we try to address in this prototype. So our use case is like a rare disease researcher. He or she, obviously like a non-profit researcher, he or she wants to access like a patient data with certain phenotype, and the data that he or she is looking for is like sensitive in nature, right? So it's like well protected, often behind like a proxy or like firewall, and the data provider or like a data owner, they also have some restriction like who can access this data set, right? Like, so here, like I depicted like a picture of two registries. So as you can see, like in the Italian registry, the data provider is like super cool, right? Like you say like anyone can access this data, including like a profit research. And this is like other data set, which is depicting like a registry in Netherlands. And this particular data provider, he has some restriction on his data sets. Like he says, like only like non-profit research is allowed, or like researchers are like allowed to use his data set, and a particular type of research. In this case, we put like a age category research. We just randomly picked one, but he has a clear restriction who can access this data set. So in order to realize like this use case, these are like steps one has to go through, right? Like first, the resource has to be found. That's not a trivial task. Then once you manage to find the resource, you have to negotiate like access to those resources, right? Like as you can see, even these two resources, we have different access conditions attached to them. And once you manage to secure like access to it, then you have to run a query and perform a distributor query in this case. And the return result should be aggregated and do your final analysis on that result. So in order to implement this use case, as I said, like we reuse like mostly like existing software components. So the first of those components is like this infrastructure, ppdl infrastructure. So basically like we use this infrastructure as a broker service. So what it does is like it coordinates like communication between the data requester. In personal train paradigm, you can think that as like a train and like a data source. Yeah, in PHT, like you think them as like a station. So for this prototype, we reuse like instance like set up by master team. Anani and Johan helped us here. So here you can see like the schematic view of like this infrastructure. So as a data requester, you send a request to a server. So in this case, like this is like a ppdl server, which checks like the person who is sending request and where this request should be sent. So it usually like as a data requester, you send like a Docker image to the server. This server send those Docker images to data sources, which they call as nodes. And the results from those nodes are like collected back in the server and given back to the data requester. The next component that we used was like a fair data point. So as I said, like a fair data point is like a metadata provider. It provides like access to metadata of your resource in a fair manner. I will explain this part later on in the slide. So fair data point has two functions, right? Like two primary functions. First, it let like a data owners to expose their data sets in a fair manner, or like description of their data set in fair manner. And it let like a potential data users to discover this information and yeah, hopefully like make use of them. And you can also see like a fair data point as a kind of gateway to your data repository. It just describes like access to your repository, any restriction like enforced by the repository. And any like a modern like a software fair data point also has like a API for creating and storing and serving metadata. So you can still hear me, right?
That's fine.
Yes.
Are there any questions up to now? Any concepts that are unclear? Because for some of these participants, some of these concepts like fair data point may still be rather new. Is there any questions at this point?
Yeah, they're using a Docker image is the standard way in the personal health trains?
No, not really. Like for this infrastructure, that is the standard way. In personal air train, like that is one way, but you can use other mechanism too. Just APIs, for example, for communicating or like communicating between like node and train. Yeah, sorry, I asked like if you heard me because for me, things got like silent. So I thought like some connection issue on my side. Sorry for that. So let me move forward. So with fair data point, like we basically like provide like a metadata, right? Like we just provide like layer of information via fair data point. So when you get into the first layer of fair data point, you get like a metadata information about the fair data point itself, which we call it as a repository. So things like who is the owner of this repository, what kind of organization is behind this repository, things like that. And within this repository, you can like classify your resources in different catalogs, which we call as a catalog. And within the catalog, you find like different resources. For this use case, it's a data set. So you find like a description of the resource, like a description of the data set, like what is this data set is about, and what kind of variables this data set has, and different distributions like associated with this data set. For the VW data prototype, what we did was like we extended like a fair data point behavior with the use condition metadata. So we attach like use conditions to a data set. So that's the only custom extension that we did for fair data point for this use case. And for all of this, we use like existing standards. For example, like for describing repository, we use like RE3 data standard. And from catalog all the way up to distribution, we use like DK2 and DC terms. And for like describing like a data use conditions, we use like a ICO ontology for it. So when I say like a fair data point provides like metadata in a fair manner, meaning like it provides like a description for both human and machine. So as a human, like when you go to fair data point, you get like a HTML page of a description of the fair data point. So you just read through the HTML page, and if you want to populate the fair data point, you can make use of like the web form offered by fair data point. And as a machine, if you go to the same link, you see like RDF back. So this information is like well encoded with like a different ontologies. So machine can like go through them and read it like if they know how to manipulate like or how to understand this ontological concepts, of course. And also like, yeah, as a machine, like you can use APIs to store content to a fair data point. So the next component that we used was like a kind of semantic component. It's not like real software components. It's like a bunch of ontologies. As I said, like we use like ICO ontology to describe like a data use conditions of a data set. And we chose ICO for this use case because ICO has quite a lot of duotherm in it. So they made like their concepts around duotherm. And duotherms are like quite often used to describe like data access conditions in biomedical domain. So we thought like, it's a good match for us. That's why we chose to use ICO. And to describe like the train or like a purpose of use, like the person who's sending this query, to describe the purpose of use, we use like a software ontology. Other reason why we chose software ontology is also like both ICO and software ontology were built on top of like information artifact ontology, which made like mapping easier for us. I show later on like how this mapping made use. So the next component that we used was like a triple store. So in this case, we use like a GraphDB. So the reason why we chose GraphDB is like this is like a one view triple store still offers like the free edition of the software. And with GraphDB, like we can also like secure like content of your triple store by enforcing like authentication. So that's also one reason why we chose this GraphDB triple store. And GraphDB also has like a good reasoner, which help us in our use case when it comes for like a mapping ICO and software ontology. So this is a architecture of our prototype. So data requester, so it sends like its Docker image plus its metadata via like a ppdl server. So this Docker image and metadata file are like sent to a node. So what you see in the metadata file is like is again like RDF file. So the description of like a data set of interest and like the purpose of use described by like the data requester. So these two artifacts like a Docker image and the metadata turtle files are received by a custom Glue API that we made. So this API is just coordinate like a connection between different components that I described now. It doesn't do anything fancy, just coordinate the connection between different components. So first it go through the metadata turtle file to find like appropriate data set for this use case. So for that it go through fair data point. So it consumes all the description from the fair data point, go through it and finds like appropriate data set that can be used for this use case. Once the data sets are found, it matches like a data set's use condition with the purpose of use. For that, it uses like the reasoner service offered by like GraphDB. So here, like we deposited like both those ontology that we used in this use case, ICO and software ontology, and we made like a link set between these two ontology. So these link sets are like used for computing like the match between like a purpose of use and data set use conditions.
Thank you, Rajaram. Marco raised his hand.
Yeah, I was thinking, Rajaram, that maybe for I don't know the background of all the audience here, but maybe for those not so familiar with triple stores and such, maybe you can elaborate a little bit on the relation between a fair data point as a metadata store and GraphDB.
Okay, so as I said before, like we use fair data point to host only metadata about your resources, right? Like it contains only description of your resources. Again, as an RDF, fair data point is as its own store. So all the description about your video sources are like captured as an RDF file and hosted by federated point. As I said before, for this use case, we are going to use like RDF sources, meaning like the patient registry that are like RDF by default. But for hosting those RDF files, we use triplestore. Triplestore are like a special type of stores made for hosting RDF files and query those files. So yeah, with federated point, we describe like the locations of those triplestore, and in this case, like this triplestore has access restriction. We also describe that you can't like just get into the triplestore and do a query, because you need like a proper authentication to get into there and do a query. So those descriptions are hosted by federated point, and the actual data is hosted by like the triplestore in this case. Does it help, Marco?
Yeah, I think so. So the graph DB database is the metadata store, right? That is how it's implemented.
So no, it's also used as actual store, right? Like the metadata are hosted in like a federated point also. Oh, also yeah, it's big detail. Like also like we use sometime like GraphDB was like a metadata. Yeah.
So you have it as files, and there's the triplestore to help with actions. Is that how we should see it? Okay. Yeah.
So yeah, now I'm going to get into the prototype itself. So we made a video of the prototype because it's really complex to show a prototype live. So when I show this video, like this is what you have to remember. So the top windows, the Jupyter Notebooks windows, they are like trains or like requests windows. So those windows, like I described, like Docker images, and the actual Docker image and metadata like sent to a ppdl server. And in the bottom, like the terminals, like the black windows that you see, are like actions that happens like when those trains are sent to a source. So in our case, we have like two data sources, right? So station 1 and station 2, and what kind of actions happens there. So those are like those middle windows, and the lower window is a result window. Once the train is sent to this station, and they do give you some response back, and this window is like to show those responses. Sorry, it's like extremely like a computational kind of prototype, but I hope like you understand it. I show my video now. I also talk through the video, but we also have like a subtitle. For now, I close it. Later on, if you want to watch it with subtitle, you can make use of the subtitle, but I talk through it while the video is playing. So here I'm sending the first train. So this train is like for a profit research. So to get like a number of patients for a profit research, the purpose is really clear here. So when I send the train, both the nodes will start getting the request from the server, and they do run your Docker images and get you results. So here you see like the station 1 already computed like our query. So in order to see the result, you simply substitute like the result ID and run it, and you see the results back. So here, this particular data station gave you like 2 patients, and this station doesn't have any restriction at all. Anyone can get data from here, even if you do like profit research, no problem at all. But this station, the one on my right side, have some restriction. They don't allow like a profit researchers to do anything with their data. So when you look into the result of that station, and they clearly say like, okay, no access interface found, because they use condition of train and station are different. So now I'm sending like different query. So in this query, I'm asking for data to conduct like a age category research. Let's see what happens now. So let me start with a result from the Saigon station, because they didn't give us like a result for the first query. For let's see like what they did for this one. So I'm just highlighting like what happened in the first query. For the age classification query, so they did give us some result, and they said like, okay, you can have like a 5 patients for your research. And as the first one didn't have like any restriction at all, like they are not going to stop you running this query. So, but let's check the result from that query. So,
Rajaram, can I ask you something? So, so behind the scenes, so what is the role of the Docker containers here? How are they invoked? At which point exactly?
So what happens now is like the reference to the Docker image, like where I sent to this nodes, right? Like so those Docker images, like they contain like a Sparkle query plus metadata of why they are like running this query. So the Glue API that I showed, it actually like take those metadata and query and run them before send result back to the server. It actually like how to say like check if this query result can be actually sent back or not.
But is this so the Docker image is created in this Jupyter notebook below what I can see or something?
Oh no, like this Docker image is pre-created. So what you do in this Jupyter notebook is like simply send like a pre-created Docker image on the top part here, and the bottom part you see the result from the node related to the Docker image that you sent.
So you add the task specification as a parameter to the existing Docker image.
Yeah, exactly. Like or like the use conditions, like why you're using it.
And what then exactly is in the Docker image? So it contains all the code that needs to be run, but that's the Sparkle engine, or
so in this case,
Docker
like
image?
in this case, it has like a query, just Sparkle query. It contains only Sparkle query, and like some API calls to interact with the Glue API that we made. That's what the Docker image contains in this case.
Because the data source contains the engine itself, the Sparkle engine.
Yeah, exactly. And also like when the Docker image is sent to the data source, the Sparkle Sparkle like endpoint URL is not known to the Docker image. So those things are like computed when the Docker image is executed at the source. So nothing from the source side is exposed in the Docker image.
Okay, that helps.
So yeah, so yeah, like as expected, like the station 1 still gave us result. So nothing went wrong there. So that's it, the demo. I share this link to the video later on. You can watch it. So now I have to maximize my screen. Oh, sorry. This is a little bit messed up. Sorry. So I had like a few slides just in case like if my video is not going to work. But yeah, in this case it worked. So I'll skip those slides and directly get into like to-dos. So what I showed you here is like a kind of toy example, right? Like it's not like a really big data set. So the number of like patients that we had and the element related to the patient that we are like a really minimum in terms of triple, like not more than like 1,000+ triples. So in the future, like we would like to deploy this approach in bigger data sets and see like how it performs. And the access condition model that we used for this prototype, or like the access condition that we used in this prototype are like a bit limited. Yeah, it's not like properly modeled. And during the VW data project, like Katie, she also did some investigation into like different like ontologies in this field. And what she found out was like none of those ontologies are complete. So she made a application ontology by connecting all those different ontologies. And when she found some missing concepts in those ontologies, she filled in those gaps. So in future, like we would like to use this ontology to describe access conditions. And the ppdl node infrastructure that we used, it didn't have like the fair data point behavior. So in theory, like the node part of this infrastructure should have this behavior. So in future, like we would like to collaborate with like Vintage 6 people to implement this behavior directly to the node. So one less component that we should worry about if it's supported by ppdl node themselves. So that's something we want to do in the future. And the access conditions that I showed in the scenarios are like extremely simple. So things like, you can use it if you're a non-profit researcher, or you can use it like if you're doing this particular research. These are like one condition, right? But in reality, the access conditions are like extremely complex. So we also like to use those complex conditions, or like describe those conditions and use them in the future use cases. Yeah, that's it. With that, I would like to conclude my talk, and I'm happy to take if there are any questions.
Thank you, Rajaram. That was very interesting. Maybe I can ask the first question, also following up on Marco Sprout's question. So in the case you want to train a more difficult model, a statistical model or machine learning model, or whatever, I guess the Docker container would contain also some software, and I think that is also used already in the Vantage 6 pipeline, right?
Yeah.
But how does that affect actually the work that you are doing here? And can you, for example, then also specify the computational requirements of the Docker execution together with the Docker with the query?
So in those cases, like we still might not have big of a complications, right? Like because we have to simply trust like those Docker images, because even here, like in the Vantage 6 infrastructure, they do run those Docker images, right? Like you can't send any Docker images. So you have to have like a bunch of pre-approved Docker images. So in terms of having some trust on those Docker images is already solved by Vantage 6. So the only thing that we went using this approach is like the purpose of use, right? Like if the purpose of use is matching the use condition enforced by the data owners. So that's the only venting that we can do here. The other thing is like if you make it like a little bit like a more generic, then you send a Docker image to a station. Then the station, in the station, we can also, if you have like the station description, station can also say like what are the computational like capacity it has. Then we can also match some metadata from your Docker image against that. Then we can also say like it's also computationally like expensive, I'm not going to run it.
Yeah, that would be my proposal indeed. Yeah, because many of the stations that we have running actually have almost none computational capacity behind it, right? They host a Sparkle endpoint and a GraphDB, but that's basically it.
Yeah, that's true. And in this case, like we didn't use any station metadata itself, right? Like we use some metadata about like the sources, but in this approach, we didn't show that. So we will have like extra component, like a station metadata provider. So you do extra matching there before even like doing any computation and send that response back.
Okay, thank you. Are there other questions for Rajaram?
Well, I've sort of following up on this, sort of request on something that maybe we should do as a personal health training community, is work these scenarios out a bit more. Also, I think the use of Docker can actually be confusing in our demos, because we have a preconceived idea of what Docker images are for, and here they're used in various ways. I think they're even used just to send messages around, and that can lead to some confusion. I also think there's scenarios where there's actual algorithms and compute capacity sort of sent with the Docker images, but also scenarios where the algorithms are actually, when you have powerful data stations. I think it's also useful for people to get more aware of how important it can be to have more powerful data stations. For me, it's also a trust issue. I would trust it more if I have a certified algorithm tested that is on the data station, rather than have Docker images coming in and there's trust that everything has been tested properly. But I think we can work out those scenarios and show which potential implementations like Docker images can fulfill certain roles. But I think we need to elaborate on that a bit more than we've done so far. And maybe the question is then, Rajaram, do you agree?
Yeah, I do agree. And also like, some of those things are like details, right? Like the architecture that Louis made. So he also tried to address them, but not like so detailed. But it's better to think about it and
and expose it.
Yeah,
disseminate it.
Yeah.
And would I be right that if if the power is at the source, both the compute and the metadata, etc., that then you wouldn't need all the capacity of Docker images, then maybe Fire messages or something like that could be sufficient, that Dockers would be overkill.
Yeah. And also like you also don't have to send Docker images necessarily as like a train, right? You can also simply send a query plus metadata. So the use cases like Peter was describing, like for that use case, it also works. So only thing that we check is like if that query is malicious or not. So then like we have different small like message sending like a service on your station side. So a Docker image will be like a substitute as a kind of query later on, like instead of query, you send a Docker image, that's it.
More questions?
Yeah, I'd like to, this was a very insightful talk. Thanks, Rajaram. But I was also wondering about the privacy compliance and compliance stuff. So this needs to be implemented by each data node in this design. And also in your case, you do filter on whether a row is allowed, an item, but there are more rules to be implemented than to be privacy compliant. Like you can only return if there are more than 10 items or something. Those kind of rules would also need to be implemented in real life, right?
Yeah, exactly. And also like over time, like it should also be expected by like the query center. They should also expect like it's not like a live, right? Like you send a query, you have to wait because there are so many computational things to be done. So they should wait for those things to be done, and probably like also get the results via like a secured environment, right? Like in this case, whoever has this ID can simply like get this results. But in the future, like we want to have like a different mechanism. So maybe like a token sent to you or like some kind of authentication, sophisticated authentication mechanism to see those results even.
Yeah.
And maybe it's worth mentioning, Rajaram, the sort of follow-up of this work also on the modeling, that in this European Joint Program Rare Diseases, there's a task force that is working on this. There's also an international rare disease research consortium that also has a task force. They work together, but they also have a task force to work. And they, for instance, came up with the idea of common consent elements. And together with Katie and Mark Wilkinson, we're planning to make an ontological representation of that. I think what is also worth mentioning is there we try to separate the information about data use conditions and the actual checking, the decisions on using that for making the decision on whether something has access, so that we don't sort of make our lives too complicated when we're working on the representation. That in the end, later on, it needs to be fully, if they want to use it for decision support, it needs to be fully tested and rigorously tested, etc. But yeah, first steps first. Get the information clear for machines as well.
I have one more question. This is all RDF based, yeah, so with triplets. But I'm not well enough into SparkQL, but does it also support relational database queries? Because some data points will only have a relational data point, and ultimately you want to ask every data station the same question. So how would that work in a bigger context of your prototype?
So as I said, like for our use case, like we started RDF, right? Like because to avoid some things, right? Like for example, like making these matches, things like that. If it's an RDF, we can make use of the reasoners to do this. But if you have like a tabular databases, we can still do it, but you lose some capacities there. So those data sets, like say like they are not using any coding system at all. If I have to understand like the data use condition of your data set, then I might have some bottleneck, you know, like that's where like RDF helps a little bit. So then it standardize it, but it's not like stopping it. We can use it, but it's going to be really complex. But like recently, like there were like some advancement in like connecting like RDF to tabular world. So we have this technology like RML. So you compute RDF or like generate RDF on demand. So you have your tabular database as it is, and you have like an interface, RDF interface on top of it. This RDF is generated when you run a query. So we can also use those tricks.
Ah,
yeah.
Okay, what's it called? This
RML.
RML.
Yeah, RML D2RQ. I'll send some links in the chat. Yeah. If you use RDF, is good. If you don't use RDF, like then it's giving us unnecessary complexity.
Okay, thanks for the clarification.
Yeah, no problem.
And maybe I can explain a bit about what we typically have as our general approach to this. Is that the steps we take is first we want to represent the knowledge, which the first step is actually a human activity. Just see if we agree on what things mean. And then the closest way to represent that is actually ontologies, because they are made for knowledge representation. And then from there, you can look at various other types. So that's our typical approach. If you come from for instance, relational structures, their power in representing knowledge is a little bit less. So you might get into certain issues there in underrepresenting or not clear representations. So this is typically how we go about things. We know that other people do it from the other end, and then because of all the technologies that Rajaram was talking about, we can actually make them work together. So luckily we have these technologies now, so we don't have to fight about it. We just use both.
Okay, more questions?
I think I missed one step. If I understand how the train find the appropriate filtered point over the resources.
So in this case, like each node has its own fair data point. So when the train comes to the node, we first take the metadata RDF file supplied by the train. There they describe like what kind of data set they're looking for. Like they say like, I'm looking for patient data.
Yeah.
So take that as an example, or like for this disease. So that description, we try to match against like a fair data point that node contains. So then we find a data set, and if that data set has a triple store behind it, or like the data set is deposited in a triple store, then we take that triple store URL. So
okay, so the first step to do this is to make the train to find the filtered points. But how this could happen, because the current architecture I found in the personal health chain architecture has centralized directory for all the personal for all the fair data points. So it's a centralized directory stored all the information about the fair data point in a closure system. So it's not the concept of it's not comply with the concept of open science, but just centralized directory. Also, as I discussed with Marco last time, probably it's better to have something like router. So another type of fair data point, but specifically responsible for the routing of the router. So for the routing of the fair data point, so you can have you can use this specific fair data point to find the ending point as the fair data point as the ending point, or the gateway fair data point. So then the gateway fair data point will let the train know where the data sources are. So you don't have to have centralized the directory, but yeah, that's what I want just to mention.
Yeah, in this case, we took a shortcut because we don't want to touch more coding, right? Like this behavior should be implemented in the ppdl server to vent nodes of interest. So in our use case, we don't do it. We simply send like all the nodes registered in that network. So, but this behavior should be implemented in the server side.
Yeah, and maybe Raja can help Chinchin a little bit with I think the question that relates to what Chinchin is thinking about is, do we need a central directory of fair data points, or can that element also be distributed?
Mm-hmm.
Maybe
Yeah.
also interesting to talk to Xiaofeng, my postdoc, on this, because he's very much interested in the findability of these fair data points and search engines that can find the relevant fair data points that contain relevant data. There is also a session he organized together with some others, Michel, for example, in the biohackathon, where this is going to be further explored.
Yeah,
I
missed the first part, Peter. Did you mention some names or who was?
Yeah, Xiaofeng, my postdoc data steward, is working on this aspect.
Okay, so maybe Chinchin and he is the he.
Yeah, he.
Yeah.
Should talk. Yeah.
Yeah, sure.
It will be a good chance for me to talk to him.
Yeah, and you can even talk in Chinese, so that's fine. Okay, are there any other points? Any other questions?